In the beginning, there was nothing. And then there was something. A bang. A big bang. Not the TV show. An actual explosion which caused the birth of the universe 13.8 billion years ago. The universe is everything.
We know this by studying electromagnetic radiation that is emitted from stars and galaxies. After the Big Bang, the universe continued to expand, going faster and faster, and continues to expand today. Why does it expand? Like much of science, we don't know why, but we can assume it's an effect of the dark side of space. Dark matter. Dark matter makes up 27% of our universe. Dark energy takes up 68%. Everything else, all the little stuffs like planets, Earth, and water, add up to less than 5%. 13.6 billion years ago, the formation of stars began. All the hydrogen and helium in the universe slowly moved together due to the mutual gravity of all the particles. Hydrogen and helium are beautiful things called elements, by the way. The universe is full of elements. They are all organized on this nifty little chart. Some old guy named Mendeleev got bored one day and organized everything in existence into this chart and called it the periodic table of elements. Each element is a box. Each box has letters, symbols, and numbers, atomic mass and weight. Back to the universe. 13.3 billion years ago, mass star formation began and the universe wanted to heat up again. So it did. And it got really hot. 13.2 billion years ago, the first galaxies formed. 12.6 billion years ago, the Milky Way galaxy formed. Home sweet home. 11 billion years ago, the universe wanted to not be hot anymore. So it cooled down, leaving all of its molecules to come together again in a gas, formerly known as a molecular cloud. After being in a molecular cloud for a while, gases decided they no longer wanted to be a gas. This was called solar nebula. Over time, particles rotated under their own gravity until they wanted to meet each other. And after an intense matchmaking session, hydrogen and helium married with each other to form the sun. Currently, hydrogen and helium react with each other in the proton-proton chain. This creates hydrogen out of helium in a process called fusion. When it happens, a gamma ray is released, which gives off light and heat to the sun. As the sun got hotter and hotter, other particles got more and more cool until they began coming together to become floating hunks of space rocks. Some call this the condensation theory. This theory is used to explain how all of our planets were formed, from dwarf planet Pluto to a special little planet, you may have heard of it, called Earth. The Earth was formed 4-point-something billion years ago when small chunks of rocks got too clingy to Proto-Earth and smashed right into it. The little stuffs that came off of Proto-Earth got stuck into the gravitational field outside of Earth and became Earth's BFF, the Moon. Earth went into an intense fight with a bunch of meteors, causing the Earth to be covered in lots of molten lava and volcanoes. More on this later. The lava then proceeded to spit out a bunch of gases into the atmosphere. Rude, including water vapor. #Vape Nation. Do you even vape, bro? Asked the sky, as water vapor condensed into clouds and rained for 1,000,000 or so years. The rain formed oceans, like the Atlantic Ocean, and the other ones. The flooding was so severe that it cooled Earth's temperatures and forced the Earth down to a crust and a core. The core is like the Earth's knight in shining armor. It protects from dangerous solar winds by creating a magnetic field. How do we know this? Seafloor spreading. At the bottom of the ocean, lava pools up, and since it contains so much iron, it magnetically flows towards whichever way the Earth's magnetic field is pointing. Why does the magnetic field switch? Because science is weird and we haven't quite figured it out yet. According to the fabulous theory of plate tectonics, first proposed by this slick-looking fellow named Alfred Wegener, the surface of Earth is divided into a bunch of plates, not dinner plates, but tectonic plates, which move together and apart really slowly to form the continents. At one point, all of Earth's continents decided to be good friends and formed one big old supercontinent called Pangaea. But even Earth is confused about how it wants to look. #relatable. You're going to change, said the Earth's core, as uranium and other radioactive metals continuously decay, releasing heat energy and forcing the plates slowly and slowly apart into how they look today. Materials don't decay like human bodies. That would be gross. There's 3 kinds of decay: alpha, beta, and gamma. Alpha decay is only seen in obese elements, which is anything with an atomic number over 51. In this instance, an element kicks out an alpha particle, which is an overly fancy term for a helium nucleus, and decays into an element with a mass number reduced by 4 and an atomic number reduced by 2. Beta decay is a lot less exciting. Pretty much, an electron or positron, because elements don't discriminate, acts as an unwanted roommate and is kicked out of the atom. Gamma decay is when an atom emits a gamma ray when decaying, which will come off as a photon. Back to the Earth. Way back when Earth was just a wee baby, it was in the Hadean era because it was all fire and lava. Get it? After a while, the Earth became a toddler and took its first steps. The first one-celled organism showed up, and we call that time the Archean Aeon. Then the Earth started to ask questions constantly, and the first multi-celled organisms came about, as well as a neat new supercontinent. Soon after that, a couple billion years, the Earth entered puberty and all these crazy vertebrae showed up. Hormones went wild over the next 554-ish million years, and the Earth grew up. There were fish, land plants, amphibians, reptiles, a new supercontinent, dinosaurs, mammals, hey, that's us, and birds. Needless to say, the Earth's parents were very nervous. All this happened in the Phanerozoic Eon, which lasted pretty much until now. This eon contained a bunch of eras, which contained many different periods, and more recently, epochs. Now that we're up to date on the geologic timescale, let's talk forces. Earth has many natural forces, but the three main ones are weight, mass, and gravity. And to understand them, we use Newton's laws. Isaac Newton was chillin' in his garden one day when an apple clonked him on the head, giving him a stroke of insight into what gravity was and how it worked. He created 3 laws. Law 1, an object at rest tends to stay at rest, and an object at motion tends to stay in motion unless acted upon by an equal and opposite force. This is also known as inertia. Law 2, force equals mass times acceleration. The mass of an object multiplied by its acceleration equals that object's force. Hooray for math! Law 3, for every action there is an equal and opposite reaction. That's like if you got really mad and punched a wall, the wall would push back on your fist with the same amount of force you enacted upon it. There's also a bunch of other wonderful and strange forces on Earth. Friction is one of them. Thanks to good old friction, you're able to walk and drive a car. Technically speaking, friction is the resistance that one surface has on another when moving over it. Without friction, we would aimlessly slide around and crash into each other like these cars here. Another wonder is the Doppler effect, which is an increase to decrease of frequency of sound, light, or other waves as they go past an observer. Everything is seen in waves. There are transverse waves, like a slinky, and longitudinal waves, the less exciting ones that move in a straight line. Waves are the reason we see the colors that we do. Different colors give off different frequencies into our eyes. Red has the least frequency, purple the highest. Those are just some of the forces Earth has to offer.
This doesn't conclude our story, because our universe expands infinitely and continues to change.
Sam, what are you doing with my physics notebook?
I was just looking at the...
Come on, dude, we're late for class.
I'm coming.